Hello and welcome to Master CFD. In this video, I'm going to show you how to generate the geometry and mesh of this product heat transfer inside a Zigzag channel CFD simulation. To start generating the geometry, first we should open a workbench window. The workbench window is opened like this, and from the list in the left side of this window, in which the name is Analysis System, you can choose Fluid Flow Fluent and drag it to the blank window. As you see, there are some sections. The first one is Geometry. If you right click on it, you can see Design Modeler and Discovery and SpaceClaim. And now I want to open SpaceClaim to create the geometry. So click on it. The SpaceClaim is opened, and now we can start to generate the geometry. This is in actually a sketch mode, and now if I want to see my actually sketch in this view, again click on this one. So a sketch is ready in the surface of Y and X, and now I want to start drawing the geometry by line command. First, by using line command, I want to draw a line which has the length of actually 2 centimeters or 20 millimeters. And now I want to define the angle between this line and X direction. To do that, go to Dimension and select the line and get Control key and select X direction. Now you can actually define the angle. By double click on it, you can change the value to 15 degrees. Okay, and now it's time to draw another line. If you drag it, yes, the length would be 20 millimeters. Double click, and now if we check the angle between the second line and the X direction, yes, the angle is 15 degrees. So it is correct, and now we can repeat this geometry by pattern. To do that, go to Design, choose Linear Pattern, and now you have to choose these two lines together by getting Control key, and then choose the direction of repeating the geometry. Here you can actually define how many of the geometry would be repeated, and here to calculate the value of a space between the actually repeated pattern, we can back to sketch mode and now calculate this line, which is 3864. Okay, so back 3864. Go to pattern, this direction 10, and here 38 64. Yes, click on complete, and now you see this is created. And next step, we want to use offset command to repeat the geometry in which the length between them is about 1 centimeters, or actually 10 millimeters. Yeah. Now it's time to I can remove this one. Okay, now I should close the channel. To do that, again, choose line command and close the channel. If you go to 3D, you see the loop of the channel is closed, but the surface is not created. We can use fill command to do that. So box select all of them and then click on complete command, so the surface is created. And now the geometry is ready, and we can transfer it to Ansys Meshing to be meshed. So close the SpaceClaim window, and now double click on mesh. Ansys Meshing window is opened like this, and you can see your 2D geometry, which is transferred to Ansys Meshing. And if you see the geometry in this view, you can see it better. And now it's time to mesh the geometry. First of all, click on mesh, and here check the physics preference should be on CFD. Next step, we want to give edge sizing. To do that, select edge and click on inlet and outlet of the channel together. Right click, insert and sizing. Here I want to change the type of sizing to number of division. I set number of division to 70, and here I set bias factor on this type, and the bias factor is 10. Next, I want to give size to the other edges. To do that, again, go to edge, and this time by right click select all, but deselect the inlet and outlet. Now right click, insert sizing, and set the value of element size to this value, and here no bias is needed. And next I want to activate face meshing. To do that, go to insert and click on face meshing, choose the surface, apply, and now right click on mesh to generate the mesh. So the meshing is done, and if you zoom in, you can see the structured mesh is like this, and you can check the number of elements here in the statistics section. and you can zoom out and see the other parts of the meshing of the geometry. I hope this video is helpful for you. To benefit from Mr. CFD services including simulation, consultation, and training, visit our website www.mr-cfd.com or contact us via info@mr-cfd.com.